All right, students, here we go. We're talking about multiplying algebraic fractions today. We talk about a few review topics first before we get started. Going to be talking about factoring. In algebraic expressions, you can factor out a common factor, or you can also factor into binomials, which we'll be looking at today as well. Next, we're going to be taking a look at the product of powers property. This simply says, like, if I have x to the first times x to the fourth, I can add the 1 and the 4 and get x to the fifth. Quotient of powers says pretty much the same thing, but with division. So if I have x to the third divided by x to the second, 3 minus 2 would be 1, so just x to the first. And last, we would have cross products. Cross products plays a role in multiplying any fractions, where you can simplify either in the fraction itself, or you can simplify across the problem any numerator with any denominator. So let's take a look at how this affects our first problem. I have 15x squared y to the third all over 3x squared being multiplied by 9y to the second all over 20x to the third y. Now, first things first, we're going to look at cross-canceling. You can do this problem a couple different ways. You can multiply all the way across, get everything into one simplified fraction, and then look at using your quotient of powers property, or you can use cross-canceling. And I think I'm actually going to use cross-canceling first, as well as canceling in the expression itself. So if we look at x to the second here, this just catches my eye first. X to the second over x to the second. If we have anything over itself, kind of like I say in class, you know, smiley face over smiley face equals 1. Anything over itself always equals 1. That's a silly smiley face. X squared divided by x squared would equal 1 because 2 minus 2 is 0 and x to the 0 power is 1. So these are going to be gone. Just going to cancel those out. Next, I'm going to look at maybe the coefficients. So we have 15 divided by 3. Well, 15 divides by 3. So I could say that divides or simplifies to get 5. Just chipping away at this problem a little bit at a time. Next we have, let's look at this part of the problem. If we have y to the second over y, this would cancel out, but that would leave one y up here. So I'm just going to take the 2 to a 1. Maybe next, if we look at cross-canceling, I could maybe eliminate the coefficients of 5 and 20, or simplify them, I should say. 5 and 20 both divide by 5. That would be 1, therefore gone. This would be 4. That looks pretty good to me. Let's maybe get things squared away and see where we're at. The 5, the 15, the x squared are all gone. I do have that y to the third, though. 3x squared, they're all gone, but there's actually an understood 1 there in its place, so we'll keep that 1. 9, and that's just going to be y, or y to the first if you wanted. 4x to the third. I think everything else canceled out there. Looks good. So now if we look at our algebraic fraction multiplication, we see that we did pretty good, first of all. Did really good at cross-canceling, simplifying the fractions. But now I still have to multiply. When you multiply, keep in mind that you're going to be going straight across the problem. Top times top, bottom times bottom. Or multiply the numerators and the denominators. So this is going to be where we're going to use our product of powers property. So I have y to the third and y to the first would make y to the fourth. So that means 9y to the fourth. And 1 times 4x to the third is just 4x to the third. Double check that nothing else will simplify. I don't think it does, so that's going to be our answer. That's simplifying algebraic fractions. Now that one we didn't have to factor any, so let's look at one that we will have to factor. Keep in mind these review ideas here. All right, up next we have, this is actually on number 8 on your practice problem set today, or this week, I should say. Now let's take a look at it. We have, wow, we have a lot longer one for starters. We have 2x squared plus 5x minus 7, all being divided by x plus 4, and then all being multiplied by x to the second plus 4x, all divided by x squared minus 2x plus 1. You might be already thinking kind of about what we're going to do to solve this problem. And if you thought factoring, you're correct. We're going to be starting with factoring on this problem. In fact, let's look at this top left expression here, this trinomial. We have 2x squared plus 5x minus 7. I just wanted to do a real quick review of the California method. You know, when we had to factor just an x squared or ax squared, a being 1, that was pretty simple. We could do that in our head. But this is a little bit more difficult, so let's review a California method real quick. So I have 2x squared plus 5x minus 7. California method tells me to multiply the a times the c, a being 2, c being negative 7. So if I go 2 times negative 7, that's going to be negative 14. And then it also asked me to find now factors of negative 14 that would equal b, or in this case, b equals 5. There's our b right there. And it is a positive 5, and that makes a lot of difference. So let's think about that. I got factors of negative 14, so I know one of them has to be negative. The problem also tells me that they're going to be different signs. And they have to multiply to get negative 14, but add to be 5. Now, since that 5 is positive, I'm going to go ahead and make the larger number positive because I want more positives left over. So factors of negative 14, I think it's going to be 7 and negative 2, because negative 2 times 7 is negative 14, and negative 2 plus 7 equals b, which is 5. That makes sense to me. That's good. So the last step on California method is going to your binomials. Differently than what we would normally do, we actually have to use all of the coefficients. So we go 2x minus 2 and then 2x plus 7. And the last thing we look at is simplify. Remember, I forgot that step in class. So simplifying, 2x and 2 will both divide by 2 to just get x minus 1. 2x and 7 won't simplify, so that's just going to be 2x plus 7. Let's double check that with FOIL. First, 2x squared. Outside, 7x. Inside, negative 2x gives us 5x. And last would be negative 7. Negative 7. That works. So that's going to be our simplified or factored version. Let's go ahead and write that down. I'm going to go x minus 1 and 2x plus 7. And we're just going to keep in our format here. Let's take a look at this next. Good review of California method, by the way. X plus 4. Can't simplify that at all. Let's just go x plus 4. X squared minus 4x. Can we factor that? Yes, we can factor out an x. If we factor out an x, we divide by x and divide by x, leaving us x plus 4. Hint, hint. Last one. This is going to be factored to trinomial factored to binomials. This is actually a pretty simple one, so let's go ahead and factor it to binomials. Like I said, it's pretty simple because the only thing that would multiply to get x squared is x, and the only thing that would multiply to get 1 is 1, and your problem tells you that they're the same as the first on the signs, so the x minus 1 times the quantity x minus 1, or the perfect square trinomial. Everything looks factored there. Let me write that out to the side just so we don't forget we factored to see if we could simplify. Up next, we're going to be using cross products or simplifying to see if we can simplify this problem down before we have to multiply it. I see this x plus 4, I told you, hint, hint, those x plus 4, the x plus 4 down here and the x plus 4 down here will all cancel out because they're being multiplied. This would be in parentheses, so it's all of that, leaves 1 down here, and this cancels out, leaves x up here. Next, I see that x minus 1 and x minus 1, either one of them, let's do this one, will cancel out. From there, good simplification, I think I'll regroup. Now keep in mind I have this x, so don't forget that x. X times a quantity, 2x plus 7, all divided by x minus 1. Double check that you can't simplify anymore. And I think that's it. I think we're good. Please let me know if you need some help. I am more than happy to help you via email, private comment on Google Classroom. You can even Facebook message me. Thanks for watching.